Hello and welcome to South Cle Elum, Washington. Today we're going to Peoh Point. Have you heard of it? It's a prominent peak just to the south of town. Let me give you a shot quick. We're going to be with geologist Jeff Tepper today from University of Puget Sound. And Jeff and I are going to drive to the top of Peoh Point, collect some rock samples, talk about collecting the samples and what he might be able to learn after getting a precise age and precise geochemistry on the rock up there. Thanks for joining us.
If this had been a normal year, about a month from now, some of my students and I would be coming out here to collect samples for their class project.
Yeah.
So the goal for today is to we're here at Peoh Point.
Yeah.
We're going to collect some samples. We're going to make some observations about the outcrops they're from that might tell us something about the style of eruption that emplaced them. These are all volcanic rocks.
Mm-hmm.
I think they're supposed to be lavas, so we're probably not going to see a lot of evidence of explosive volcanism, but we'll see what we find.
Kind of a mystery unit, really, as far as specific age and specific chemistry.
Age not well known. Relative to the Cascades, we're kind of far east, so it's, I guess, not entirely clear why these rocks are here. I mean, they look like the kind of rocks you'd find in a subduction zone, but they're a little too far east, and we don't know their age terribly well. So those are the kind of questions that we hope we'll have some answers to after we study the rocks more.
So how long you been at UPS?
I started in 2001, so this is start of year 19.
And this is in a more advanced class that you're preparing for, or?
Right, so this is it's Geology 304, which is Advanced Igneous Petrology and Volcanology. It's it's an elective, it's not a required course.
Sure.
So all students have already taken a course that is identification of rocks and minerals in hand sample, and then this course. And so the goal is for the class to go all the way through the process from collecting samples in the field to preparing and analyzing them chemically, to making thin sections, to interpreting the data, and then to writing up a thesis, writing up a report, which, although I don't like to say this at the beginning because it makes people nervous, but it's basically like a mini thesis.
Sure, sure.
And some years, at the end of the process, students elect to present the class project at GSA. So if there's a spring meeting of GSA that's not too far away, I've encouraged them to submit an abstract. This is such great country to work in.
Totally.
We stumbled across an interesting rock on the Olympic Peninsula, which got me interested in Eocene events in Washington. And so ever since then, every project has somehow fit into this larger question of why was magmatism during the Eocene so widespread and so diverse. And so those projects have geographically ranged from the Olympic Peninsula down south almost to the Columbia,
Huh.
the Grays River.
Uh-huh.
And then on the east side here, the Teanaway, the Natchez, and now this year some rocks up around Wenatchee, the domes that you and I visited
Sure.
last year. And
Very cool.
so it's been really exciting.
Well,
And I really, I value that students should have this experience of discovering something new. And since we're always studying a rock unit that hasn't been studied before, it's kind of a guarantee that whatever we find is new.
I'm sure they appreciate that part of it.
And I think they do. I mean, I think the end of the semester can be very stressful for people who haven't budgeted their time well. But I think most of them, if they look back on it, think, yeah, I learned a lot. And
I mean, I've only seen that scale of map that I showed you. You haven't found anybody mapping more
No.
detail with a lot of these units, have you?
no, as far as I know, the 1 to 100,000 sheets are the most detailed
Huh.
available.
How about I follow you a little bit? That's pretty easy trail. You know what, Jeff? Yeah, you mind right here?
This looks good.
That's a nice shot.
Big pile of andesite of age not precisely known, but somewhere in the 50 plus or minus 5 to 10 million year range. And so we're going to collect some samples, and we've driven up to, we can drive most of the way to the peak here, and we've had about a 10-minute walk, quite casual. And we're going to now look for some outcrops that look promising.
Let's do it. I mean, I know you don't like that word altered, but you didn't seem to have a problem with the pretty altered stuff at Saddle Rock, for instance. That looked like pretty screwed up stuff.
But that was actually better, I think, than it looked. So.
Uh-oh, something's happening. The professional's doing something.
All right, so we found some outcrops. We prefer to collect our samples from a rock that's in place as opposed to some loose boulder, which we call float, although sometimes if we're fairly confident that the float came from nearby, we might use that. So I'm just going to break off a piece of this rock and we're going to look at it and see if it looks fresh.
That's a man's man right there.
Well, I like my hammer to be persuasive.
Yeah, that's... You don't seem angry, Jeff, but just for a second there, you seemed
But I do
pretty
feel
angry.
relaxed now. Okay, so what we're assessing now is whether this is a fresh sample. And by fresh, we mean, are the minerals, the igneous minerals, still intact, or have they been either weathered or affected by sort of hydrothermal alteration? And the things we look for example, do we see cleavage faces? So as I tilt this rock to the light, do I see reflections? And the answer is yes. And then if there's any mafic minerals, like hornblende, for example,
Black?
we would hope they would be black. And this rock, they look fairly unhappy. So
The guy's furiously going through his geology glossary right now. Unhappy, unhappy.
Right. Unhappy meaning if they're unhappy, we're kind of unhappy too.
Right.
But they look oxidized. I don't see any, nothing looks very black. So I might keep this for now, but hope that we find something better later this morning. So if we're going to keep this, I'm going to record the location where we got it. And I'll do that with a GPS, and then I'll take some notes in my field notebook so that anything about the outcrop that might be relevant to interpreting the rock is recorded. Okay. So the nice thing about a GPS is you can save your coordinates and then later plot them on a map. So if you take, those of you who are considering taking Geology 307, you'll know how to do this in the spring. So I just push mark, and then I'm going to give it a sample name, and I usually give my sample names with some 2 letters that indicate the location. So since this is Peoh Point, this is going to be PP20 because that's the year, and then sample 1. So
Now, if you analyze that rock, are you grinding up the whole rock and using the whole thing?
So what we would probably, I would like normally to collect a sample that's big enough to do 2 things. So I'm going to make some powder. So we would break off a portion of it and pulverize that, and that's for the chemical analysis. And then we would have enough left over to cut a piece about the size of a domino that we could then use to make a thin section. So we want to have material for both thin section and chemical analysis from the same chunk of rock, or at least from pieces of rock from the same outcrop.
So you're not one of those cats who's isolating one mineral and just going nuts on one little grain.
No, so there is the potential. These rocks haven't been dated, at least not precisely, and it would be nice to know their age.
Right.
So we might decide to collect a sample to date, and so for that we want a volume that's about equivalent to a coconut.
Okay.
It doesn't have to be one chunk.
Yeah.
So it could be a bunch of pieces. But that would be enough for us to pulver or to crush and then go through a series of steps to select out the zircons, and that's what we would date. So if you and I come across something today that looks
Happier.
well, actually for dating it doesn't have to be happy.
Okay.
So zircons are so resistant to weathering that this could be a completely ugly, altered, weathered, crumbly rock that you would do nothing else with except date. But the zircons would be intact and pristine. So we don't really care so much about weathering for zircons. We do care about weathering for thin sections or for chemical analysis.
Got it. And what does a zircon look like in these rocks?
It's to be too small to see even with a hand lens probably. But under the microscope it's a beautiful little 4-sided prism, usually with terminations at both ends, commonly pale pink or pale orange and brilliant, so it just reflects light like a diamond. They're beautiful. So it's an arduous process to get to the point where you have separated them from everything else, but your reward is these beautiful little crystals. Very small, but aesthetically pleasing.
So there's probably how many zircons in your hand right now? Like hundreds, thousands,
well, no,
10?
probably. If we were to crush this rock and go through all the steps, I would consider us lucky to have 15.
Huh, interesting.
So this has this very sparkly face.
Can you rotate it a little bit more for us? Thank you. Yep.
So this is different than this, because this is a quartz vein that when the rock broke, it broke along the vein. So we're seeing the surface of a vein. So when the rock's been cut by veins, that's another sign that it's not very fresh. There's a vein.
Hmm.
So we'll leave this one here.
That's a leverite. You're looking at the andesite of Peoh Point. Here's a report from 1982. Roland Tabor writing to us. A rather uniform mass of highly altered hornblende hypersene dacite porphyry forms Peoh Point and the surrounding cliffs. Although it resembles some lavas of the Tainum andesite, which Jeff has studied, or the Silver Pass volcanics, which Jeff is about to study, the porphyry cuts a probable fault, separating the southwestern sequence from the western sequence, and thus must be somewhat younger than at least the Tainum andesite and the Silver Pass. It could be the last pulse of Tainum volcanism.
Or first pulse of Cascades. Okay.
A little bit of jointing here. Basically the fact I'm reading a report from 1982 about another unit called the Basalt of Frost Mountain that was thought 1982. That's almost 40 years ago.
Right.
The best date was 32 million years old, and you studied it when?
So we studied it about 4 years ago.
Okay.
And dated some zircons in some tuffs that are part of that same unit.
Yeah.
And I think the age was 51 or 50, somewhere in there.
What in the world?
So the method that was used in the 80s is based on potassium decaying to argon, but argon is a gas and it can escape from your sample, and if it escapes, then the rock looks younger than it really is.
Yeah.
So it's just a more difficult technique to use reliably on a rock. Then zircons, they're forever. So if you can get zircons out of the rock, the date you get from that is not prone to resetting or loss of lead, for example, which would make it seem younger than it is.
So this world of zircon analysis has shown up in the last 40 years? Like nobody was doing zircon work, were they?
It was much more difficult. So it has been revolutionized by the ability to work with incredibly small samples, including single crystals. So in the 80s, you could date a sample using uranium lead measured in zircons, but you would have to start with a gram of zircons or something, which is an enormous number of small crystals, and those might not all be the same age, so by the time you had dissolved them, you had homogenized what might have initially been a spectrum of ages. Now, people, including your coworker Mike Eddy, can date a single crystal, and that age, in addition to not being vulnerable to resetting, can be measured with a precision of 100,000 years or something, which sounds like a lot, to a historian, but when you're talking about something that's, 100 million years old, 100,000 years is
Seriously.
it's pretty good. It's enough that, fine details of large-scale geologic processes can be seen, whereas before they were sort of blended into, well, somewhere in the 3 million year gap this happened. Well, now we can say actually several things happened in that 3 million year gap, and we can rank them in order.
So is it a tool thing? Is it a laboratory techniques or instrumentation that was?
I think it is mostly a tool thing. So it can now be done with a laser.
Yeah.
And the lasers are not as precise as the wet chemical technique.
Mm-hmm.
So part of the advance is in more precise measurements with a mass spectrometer. But for people like me who don't have access to a mass spectrometer, the world of dating with a laser has made it possible for an undergraduate we can separate zircons. So we can do that at UPS.
Yeah.
And then we can go to Arizona and shoot the zircons with a laser, and get each individual crystal gives you a date. And you can date multiple rocks in an afternoon. If you're good at video games, you just drive around the joystick and press fire, and you vaporize some zircon, and out of that vapor, there's some lead, there's some uranium. You measure the ratio of the two, and there's your age.
Wow.
So.
I think I need to do this approach one more time. This is pretty dramatic.
Ooh. Are those CRBs in that flat mesa?
That's the end of the line right there. Lookout Mountain. And Table Mountain on the skyline, same thing.
Okay.
Well, that's our little Peoh Point show from south of Cle Elum, Washington. Thanks for joining us. Hope you enjoyed it. We're going to have to be patient. This rock, andesite, but Jeff is going to take probably months with his students to analyze the rock samples and hopefully give us very precise ages and chemistries from these magmas to ultimately see how Peoh Point fits in to the geologic history here in the state of Washington. Thanks for joining us. I love you. Goodbye and goodbye.